Hello and welcome, I'm your Code Monkey. In this lecture we're going to refactor our code from the legacy input manager onto the new input system. So the simple character controller that we made is working perfectly fine with the legacy input manager. Like I said, this one is excellent for making quick prototypes and demos. As you can see, it's super easy to use. But now let's quickly refactor this code to use the new input system instead. Also, like I said in the beginning of this course, here I'm going to be focused primarily on building this game. So for example, for any Unity tools that I use, like the new input system, I'm going to cover enough to be able to use the tool and achieve our goals in building this game. But of course, every tool does a lot more than just what we're going to use, so definitely make sure to watch the dedicated videos linked in the description. For example, the input system tutorial is 40 minutes long, covering everything you need to know about system, whereas here we're just going to learn enough to know how to use it. So let's refactor this code to make it work with the new input system. Except before we work with new input system, let's just refactor this code so we can completely decouple the input from the player class. Again, we want to focus on writing good, clean code, so we should keep all of our input logic in its own class that other scripts can access. Remember, the goal with clean code is to minimize and manage complexity. So every class should do one thing and just one thing, meaning that the player class should only handle the player, and then the input class should only handle the input. The only reason why I put this over here in the beginning is exactly to teach you about refactoring and how it's a very common thing that you should be doing all the time. This is exactly how I build my own games. I start by making a prototype and I write the input directly inside the player class, then at some point I refactor the code to split them up. So don't be afraid to refactor code, it's a perfectly natural part of the game dev process and actually a very good thing. Okay, so let's make a script just to manage our inputs. Let's make a new C# script, call this game input. Let's create an empty game object, give it the same name, input. As always, keep things clean, so put it on 000. Let's attach the script and open. Okay, so here's our script, and let's get everything related to the inputs. On the player for the input, we are calculating the input vector, then getting the actual inputs from the keyboard and returning the input vector. So let's put this on the other script. So over here, let's make a new function. Let's make it public since we want to access it from the player. We're going to return a vector2 and let's call it getMovementVector. Now here, let's really just copy paste the exact same code that we have on the player. So let's copy paste all of this. Let's go and paste it here. Okay, so we get the input vector, we get the inputs, we normalize it and then return the input vector. Okay, so that's it, super simple. Also, by the way, here we have an interesting question, which is, do we normalize the input over here or do we do it over here on the player? Both options can be valid. You can make it so that the game input class returns a regular input, or you can make it return a normalized vector. You can use either option, but whatever you do, make sure you are explicit. So over here, I am going to normalize the input inside the game input class. However, I'm also going to make sure to rename this function. So instead of getMovementVector normalized. That way it is 100% clear this returns the movement vector as a normalized vector. Okay, great. So now let's use this in our player. Over here in our player class, we need some reference to our input class. Now later on in this course, I'm going to teach you about the singleton pattern, but for now, let's just do a simple direct reference. Again, remember, don't make it public, make it a serialized field private. So over here, let's make a serialized field private of type game input, and let's call it just game input. Okay, so we have this, we're going to drag it in the editor, then over here, we simply grab the vector2 for the input vector, we simply go into this one, and we get the movement vector normalized. And okay, that's it, no more errors. Let's just make sure to save all of our scripts. And back in the editor, let's go into the player and just drag the reference for the game input. Okay, so just like this, everything should still work. Everything should work exactly the same as previously. Let's test and make sure. So here we are moving, and yep, everything still works. I can move in any direction. Okay, so far so good. And what we have done here is essentially we have refactored our code and completely separated the input from the player class. This is an excellent thing, so again, don't be afraid to refactor code. Also, what we did here of putting the code in a separate class, and then doing a quick test to make sure that everything still works the same as previously, this is exactly what you should do whenever you do some kind of reorganizational refactoring. In the end, you want to end up with the exact same behavior as previously, just with the code organized in a different way. Okay, so now that we have this separate game input class, now we can very easily refactor the legacy input manager onto the new input system. So the first thing we need is to install the package, so let's open up the package manager. Let's make sure up here we are in the Unity registry, make sure we are in all, and let's scroll down to find the input system, so here it is. Let's go ahead and install. Okay, the package is installed and right away we see this message. Basically it's asking us if we want to enable the new input system. Now you could click on yes, but let's actually go ahead and click on no. We're going to enable it manually, so click on no. Then let's close this window. And now let's go up here into edit, then let's go into project settings. Then on the left side, let's go into player. And now let's scroll down, expand over here the other settings tab. And keep scrolling down until we see, yep, here it is, the active input handling. This is where you can select which input system you're using. Basically, if you click yes on that window, it would automatically set this option to use the new input system. So it would only enable that one and completely disable the legacy input manager. But like I said, the legacy input manager is still pretty useful, so normally for me, I prefer to enable both of them. So let's go ahead, click on both, and this will restart the editor. So okay, let's go. Alright, the editor has restarted, so now the new input system is now enabled. Okay, so the way that this system works is by creating something called an input actions asset. So on the project files, let's click on the plus icon, let's create something, and let's find the input actions. So we need to scroll down here, so click on the little arrow to go down and find the input actions. Creates this file, let's call this the player input actions. Okay, now let's go ahead and double click on it. And yep, there you go, out pops out the input system window. Basically, this one is where we're going to manage all of the settings for all of our inputs. Also, by the way, like I've mentioned, if you're watching this in the future and for some reason the input system got a new update and changed this window, if so, make sure you check the pinned comment. I'll keep it updated with any changes on anything in this course. So over here, we've got the action maps, then we've got the actions, and then we've got properties. Now, action maps are how you can have different maps. For example, one action map would be for the player whilst walking normally, and you could have another one whilst driving a vehicle. Then for the individual actions in each action map, and finally the properties for each action. Again, if you want to learn about the entire input system itself in more detail, go ahead and watch my dedicated video on it. In order for this course to not be 20 hours long, I'm really only going to use enough to make sure that we can achieve our goal. So over here, we just need one action map, so let's click on the plus icon. Let's name this the player. And now for the actions, right away we have a new action. So let's just rename this one. Let's call this action move. Then with this action selected, over here on the action properties, we can select the action type. Again, in the dedicated video, I cover what all of these mean. For movement, we do not want a button. We want movement in multiple directions, so let's go with value. Then over here for the control type, for this one, let's go with a vector 2. And then let's expand our action. Over here, we can see our bindings. However, we don't want this default binding, so let's actually delete this one. Instead, let's click on the plus icon, and over here for the type, first for the keyboard, let's go with this one, up, down, left, right, composite. So this one adds essentially 4 bindings. Let's go ahead and name this WASD. Then for the up, let's select the binding. So over here on the path, let's click on it. Then we can either find it manually over here or click on the listen and now press the W button. Yep, there you go, W. Then for down, let's go ahead and listen S. Then for the left, listen A. And for the right, let's listen D. Okay, great. So with this, our input asset is correctly set up. One thing you must never forget is up here, make sure to save the asset. You can see this little asterisk here. That means we have unsaved changes. Also, alternatively, there's an autosave there. But for now, let's just manually save the asset. Okay, great. So now let's see how to actually use this in our code. There are many ways we can use the input system. One way is by using the built-in player input component. So for example, on the player, we would add the player input. So you could add this one, attach an input actions asset. So this is our player input actions. Then over here, we have various behaviors in order to be able to trigger our actions. But in this course, like I said, I'm going to be using the exact same code quality that I used in my own Steam games. So I will not be using this component. So let's remove this. Instead, I will be using the native C# method. So let's select the player input actions. And over here on the inspector, we see this nice toggle to generate a C# class. Let's go ahead, enable it. And for these fields, we can leave them all on defaults. That's okay. Let's just go ahead, click on apply. And now it's going to generate those scripts and compile them. Okay, great. Basically what this is doing is auto-generating some C# code. And on the player input actions, we can see over here, yep, we've got the generated script. If you want, you can even open this to see all of the source code. Now all of this, like it says here, this was all auto-generated, so don't make any modifications here. If you change anything, any manual changes will be lost when you save some changes in the input asset. So if you want, go ahead and read through in order to see how all of this works. But in order to use it, it's actually super simple. You don't need to worry about this script. First thing we need is to construct our script class that was auto-generated. So let's do it over here in our game input. let's make a private void awake, and on awake, let's construct it. So let's do a new player input actions. So we construct an object of this type. So we have this, although just like this, it won't be active. So we need to manually activate whatever action map we want. So let's go inside and let's go inside the player. So this is the action map that we created, and let's call enable on it. Okay, so just like this, it's really already working. All we need to do is modify our code over here on the get movement vector. So for that, we're going to need to access this. So let's actually make this a member variable. So private, let's store it up here instead of making a local variable in here. Okay. So we have this one, and then down here on the input vector, let's go inside the player input actions, inside the player action map, and then we called it move. So we've got this one. And then we defined it as a vector2. So over here, we can call read value. And this one takes in the type of the value. Now we defined it as a vector2. So let's read it as a vector2. And just like this. This returns a vector2, which is really going to be our input vector. So let's put it exactly like this. And we can now get rid of the rest of it. All right, so that's it. And just like this, we should already have everything working exactly the same as previously. So let's just do a debug.log just to make sure. So let's test. So here we are, and the output is 0, 0. Now I press W. There you go, +1, -1, left, right, and all of the ones in between. All right, awesome. So we have the new input system, all of it working flawlessly. Also, by the way, over here, we can normalize the input just like we were doing previously. So we do it over here through code. Or alternatively, we can also go into the player input actions. And over here, there's something called a processor. So you can go into this action, add a processor, and make it normalized. So these processors here can be quite useful. I cover them all in detail in the other dedicated video. But over here, let's stick with making it through code that works just as well. Okay, so that's our refactoring done. With that simple change, we are now using the new input system. So you can see how by refactoring our code to make sure to use the game input class, when we change from the input manager onto the new input system, when we made that change, we did not have to touch the player class at all. The player class just has the game input to get the movement vector and does not care what system he uses to get that. So here we have a very practical, very excellent example of the power of writing good, clean code. Because we separated things correctly, we managed to change something completely and not have to make any changes on any other class. So now that we're using the new input system, let's just quickly see one of the main benefits of this system, which is easily supporting gamepads and more keys. For example, a lot of people like using WASD, but some people also like to use the arrow keys. With this system, that is super easy to add. So let's go into the move, let's add another one. Let's add another one, up, down, left, right composite. Let's call it arrow keys. Then let's just put them. So let's listen on the up arrow. Then over here, we've got the down arrow. Then we have the left arrow. And finally, we have the right arrow. All right, so we've got all the arrows. And now we don't even need to touch any code at all. Let's just make sure to save the asset, which again, in turn, that is going to auto-generate the C# class and going to compile. Okay, so we don't need to touch any code at all. Let's just hit on play. And now if I move, we're using the WASD keys, yep, still works. And if I go into the arrow keys, yep, also still works. All right, great. Now for another one, let's make it for a gamepad. So I just connected an Xbox controller, and we can see over here on the log, yep, the game did identify it. So this is the new input system in action. Let's once again open up the input actions. And over here on the move, let's add another one. And this time, let's just make it a regular binding. And now over here on the path, once again, if we want, we can go down here and specifically find some joysticks. So you can find any of them, or once again, let's just use the listen. Now I'm just going to move the thumbstick on the controller. Yep, there it is. And now if you wanted, you could go specific and make it just work with Xbox controllers, or you can just use the generic left stick. This will make it work with an Xbox controller or a PlayStation or really anything. So let's go with this one. And that's it, nothing else we need to do. Let's just save the asset and that's it. We don't need to touch any of our code to make our game playable with a controller. So let's go ahead and test. So here we are, and first of all, if I move the keys, yep, still works. Move the arrow keys, yep, both of them works. And now if I use my gamepad, and yep, there you go, everything works perfectly. All right, awesome. So as you can see, this is one of the main benefits of the new input system. It makes handling different inputs really super easily. As you saw, we didn't have to touch our code at all. We just had new bindings, and just like that, our game is playable with all kinds of inputs. So here you can really see just how powerful the new input system is. Okay, so with this, our basic character movement is working great. We can walk around, everything looks great. Now in the next lecture, let's apply some collisions to our player. Hey again, here's another quick intermission. I hope you've already learned a ton from the course. Have you seen the benefits of writing good clean code? Has the course already helped you understand some more advanced concepts? I really hope the answer is yes to both those. Remember to follow the website page as you follow along. I will be adding frequently asked questions to every lecture. If you ever get stuck, you can just download the project files for a lecture and compare with your own. And definitely check out the related videos when I reference them. This course is focused on making this game, but you should definitely learn more about some of these concepts in more detail, and you can learn that in the videos that I mentioned. By the way, if you're watching this right now, this is the secret callout, so go ahead, post a timestamp in the comments with a nice monkey emoji. I want to see how many people make it this far. Okay, so that's it for now. Let's go to the next lecture.